Hey Manuel, it's Mr. B. No musical intro. I feel bad about that, but I could sing, but nobody wants to do that. Nobody wants to hear that. So here we go. This is an inequality, and it involves an absolute value. So with an absolute value, there's going to be and an inequality, but absolute values are a little tricky. You have to think a little bit about it because there's going to be a range of numbers. So on a number line, I could have solution. I'm going to have a couple of points, and it could be my solutions are to the left of this point and to the right of this point, or it could be in between these 2 points. So the way that there's a lot of different ways to do it, but I like this way because it just makes I think it makes sense. And what we're going to do is we're going to, for a second, just pretend that this is not an inequality. Okay, we're going to think of this as a regular equation, and so I'm going to rewrite it as 4 times the absolute value of 6 plus 2 times s minus 27 equals -3 instead of less than or equal to. And the reason I want to do that is I want to find these 2 points, and then I can do a real quick test to see where the solutions are. So I'm going to add 27 to both sides, and I get 4 absolute value of 6 plus 2s is equal to 24. And then I divide both sides by 4, and I get absolute value of 6 plus 2s is equal to 6. Okay? And since it's absolute value, if I end up in here with a positive 6, the absolute value of positive 6 equals 6, and the absolute value of negative 6 also equals 6. So if I end, for whatever value of s, I end up with either a positive or a negative 6, the absolute value makes it positive 6. So what we do then is we just say, okay, 6 plus 2s could equal positive 6, or 6 plus 2s could equal negative 6. Okay, and then we solve real quick. Subtract 6, 2s equals 0. I'm sorry, equals 0. So s could equal 0. Or subtract 6, 2s equals -12, and then s would be -6. So that means my little test point for my range of values are -6 and 0. And to test, I'm not going to go all the way back here. I simplified the equation to right here. But in order to test it, I have to rewrite it as an inequality. 6 plus 2s absolute value. And I'm going to again use less than or equal to 6 right here. Okay? And maybe I should write that up here. Absolute value of 6 plus 2s less than or equal to 6. And I have 3 regions. Region A right here, region B, and region C. And let's just do a quick test. -7. We could do it in our head, okay? So, but I'm going to write it out. -7. Okay, so I'm testing 6 plus 2 times -7. And you don't have to write this out, Manuela, if you can do it in your head. Is it less than or equal to 6? 2 times -7 is -14. -14 plus 6 is -8. Is the absolute value of -8 less than or equal to 6? Well, the absolute value of -8 is 8, and 8 is not, let me do this, is not less than or equal to 6. So that region is a no. So in here, let's try -1. So here's my -1 test, and this one we can do in our head for sure. 6 plus 2s absolute value, is that less than or equal to 6? 2 times -1 is -2. 6 minus 2 is 4. Absolute value of 4 is 4. Is 4 less than or equal to 6? The answer is yes. So this region is good. And right now you actually know this is your answer, but let's just test. It's really simple. Let's just to be sure, in case we made an error here, let's test +1, which is to the right of 0. Absolute value of 6 plus 2 times 1. Is that less than or equal to 8? absolute value of 8 less than or equal to 8. 8 is, I'm sorry, not 8, it's 6. Sorry, our test is 6. Hopefully you caught that. Is 8 less than or equal to 6? It is not. So this is out. So our region is from -6 to 0. And I'll write our solution in pink. So the answer is -6 less than or equal to s less than or equal to 0. And I know it's not just plain less than, because in the original equation it's less than or equal to. If this equal to symbol wasn't there, then it would just be plain less than. All right, hopefully that made sense. You have my number to text if you don't understand. Please do. I'll be happy to help you. Have a wonderful weekend, and we'll see you when we get back in school.